Now we'll be going through collision of particles problem. So over here I extract some questions from tutorial 10, which is purely on collision of particles. Now for this question, we have two identical billiard ball move freely on a horizontal table. So ball A has a velocity of v0 shown, and it hits ball B, which is at rest at point C, defined by theta equals to 45 degrees. Knowing that the coefficient of restitution between the two balls is E equals to 0.8, and assuming no friction, determine the velocity of each ball after the impact. Okay? So the very first thing that we'll do is we'll put down our notation for En and Et. Okay? So En is in the collision line of impact, Et is perpendicular to it. Okay? So En, I'll write it down, is cosine negative 45 and sine negative 45 because it's measured from the positive x-axis, negative 45. Et, cosine 45 and sine 45. We know that v0 is constrained within the I direction, so we can just write this down for now. Next, we know that v0 can be split into En and Et directions. And we know that in Et direction, there is no impulse. So v1 in the Et direction is same as v0 in the Et direction. Alright, then we use conservation of linear momentum, which is along the En axis. And why is that so? Is because these two billiards are actually on the horizontal table, so there's no other forces, and hence conservation of linear momentum is conserved along here. Okay. Next, with the conservation of linear momentum, we can remove the constant value of m, so I cancel all of it. I know that VB starts from rest, initially starts from rest, at rest, hence it's 0. Then we can express V0 in terms of V1A in the normal direction and V1B in the normal direction. Okay? Next, I try to express this in terms of V1A in normal direction, and why is that so? Later we'll find out. Okay? Next, we'll set up the restitution equation, where v1a in the normal direction minus v1b in the normal direction, okay, is equals to negative e v0a in the normal direction minus v0b in the normal direction. Remember that since b starts from rest, it will go to 0. Realize that we have 4 equations, 4 unknowns. So over here we have the first unknown, which is v0. Second unknown is v1 in a v1. Next, we do not know what's v1a in the normal and v1b normal. So 4 equations, 4 unknowns. So with this, we just do the math and can solve for these unknowns. So just look at the solution, which I just the workings which I put up over here. So v1b in normal direction will be 0.63634 v0, and v1a in the normal direction is 0.07 v0. Okay. Then for v1a, we can use it's separated into En and Et directions, remember? So the normal direction you can take from here. However, for Et direction, we know that v1 Et is equal to v0 Et, and we know that v0 Et is cosine 45, and that would be square root 2 over 2. So that's it. So that's the answer to solve for this tutorial 10 question 3.